Hi friends, in this problem we are given Sn is equal to sigma phi equal to 1 to n ai. That means a1 plus a2 plus a3 plus a4 up to an. That is Sn. Right. Now we are also given when limit n tends to infinity an is equal to a. That means these items a1, a2, a3, a4 up to a infinity, they are converging on a. So for example, it could be like 0.9, 0.99, 0.9999 and all. They could be converging to 1 or they could be converging to 2, whatever. Right. So A is a finite number. That means AN, this series, for example, if you start 1, 1 by 2, 1 by 4, 1 by 8, etc., this will go down to 0. Right. So similarly, this is some series or this is some sequence which will converge to A. Right. What does that mean? If it is converging to A and when n is tending to infinity, when n is very big, there's not much difference between an and an plus 1. Right. Because they are very close to each other. Okay. Now let's look at this. Sn and when n is tending to infinity, an plus 1, everything will become A. Right. Because it is converging to A. Now let us look at this. Sn plus 1 minus Sn. What is Sn? Sn is a1 plus a2, a1 up to an. Sn plus 1 is a1 up to a1 plus a2 plus a3 up to an plus 1. What does that mean? Sn plus 1 minus Sn is an plus 1. Right. This one, Sn plus an plus 1 is equal to Sn plus 1. Right. The difference is actually an plus 1. Right. Now, here n is tending to infinity. N is tending to infinity. That means n plus 1 or an plus 1, both of them should be equal to a. Right. Because n is so big, then it practically doesn't matter. An or an plus 1 or an plus 2 or an minus 1, when n is tending to infinity, it should be equal to a. Because here it is given, this an is convergent. So what we are given? This is equal to a by under root of, again, sigma I equal to 1 to n I, which is nothing but, what is this under, in this under root, it is nothing but 1 plus 2 plus 3 plus up to n, right, which is nothing but n into n plus 1 by 2, right. Basically this problem is a by under root n into n plus 1 by 2. Obviously when n is tending to infinity, right. Obviously, when n is tending to infinity, this, even if we take this root 2 upside, it will become under root n into n plus 1. When n is tending to infinity, obviously this denominator will become very, very, very big. So this ratio is actually equal to 0. Right. Because root 2a is a fixed number. It is already given. This function is actually converging to a is a fixed number, and the denominator is actually infinity. So this is actually equal to 0. Right, Sn plus 1 minus Sn is nothing but an plus 1. When n is tending to infinity, an plus 1, an minus 1, these and all should converge to a only. So basically the numerator is a and the denominator is actually 1 n into n plus 1 by 2, square root of n into n plus 1 by 2. This n into n plus 1, this also, this number becomes infinity, it goes very big as n tends to infinity. So the denominator is very huge, denominator is going to infinity. Numerator is a fixed number, a small number, whether small or big doesn't matter. It's a fixed number, right? It's a fixed a because this sequence is converging, right? So ultimately the limit is actually equal to 0. Simple problem. Just that we need to understand this concept of this an converging to a, right? That's the trick here. Thank you, guys.